Hello everyone, I'm Victor Hugo Germano. This is the demo video for the capstone project for the master's program on applied artificial intelligence. This is a adversarial speech attack demo. The idea behind it is we get an audio input and transcript the input using OpenAI Whisper model. And the adversarial attack is a way to add a small perturbation that sounds like static, but affects the model in different ways. So let's record an audio. So this is the audio of the capstone project presenting here online to see how it works. So this is the audio of the capstone project presenting here online to see how it works. So we run the transcript over OpenAI Whispers model. You can see the both clean transcript and adversarial transcript are the same. And the audio, the resulting audio. So this is the audio of the capstone project presenting here online to see how it works. As we turn the untargeted universal adversarial perturbation, the idea here is just to add audio on top of my recording so that it makes the whisper model behaves wrongly. So as you can see, with that audio added, the transcript is different. As we see the spectrogram, it has a few changes on the spectrogram, and this is the audio, the resulting audio. So this is the audio of the capstone project presenting here online to see how it works. When we turn on the Carlin-Wagner injection, the idea is we can define which message we want to be transcribed from the model. So here, as you can see, Access Evil website is a phrase I decided that I want to the OpenAI Whisper model to transcribe from the audio. And then we see the resulting audio, we can't see the interference. So this is the audio of the capstone project presenting here online to see how it works. So just to show how this works, is the idea is kind of simple. So we get the starting audio and we add a perturbation to that audio, and using the resulting audio, we extract the mesh spectrogram features, and we pass that through the whisper model and calculate a loss. Then we back propagate that loss back to the delta, the perturbation that we added, and we wanted to have a universal audio perturbation. We just run this process thousands of times, and eventually we have a single perturbation file that can be added to any audio at inference time. For targeted interferences, what we do is we calculate the distance between the expected phrase that we want and the loss, and we try to reduce that distance over on that same processes. That's it. So here's a live streaming demo. As you can see, I just added a live recording demo and transcript of this presentation. Both columns are still the same. As I turn the untargeted universal adversarial perturbation, it changes what is being presented on the right-hand side. Over time, it drifts apart the transcription. So as I start the targeted injection, what happens is the whole transcription changes completely and it drifts away, and the model starts to hallucinate a lot on what's been said. And then you see that it has an interesting way of bringing always the same phrase, which is website, especially because as we add the perturbation to the original audio, what is happening is the resulting tokens are being pulled closer to the phrase that we organized when we trained the perturbation. That's why we're going to see a lot of website as the things that are being transcribed. This is it. Victor, thank you.